Hey, how's it going? Before we jump into the content, I just want to take a minute to thank you for stopping by the channel and checking out the content. If you like this content and you want to support more content like it, then make sure to subscribe to the channel and like this video. You can also check out the YouTube membership program and cybertrainingpro.com, where I put practice exams and other things that I couldn't put on YouTube. Again, regardless of how you support the channel and my content, I couldn't be more appreciative. Thank you so much, and let's get into the content. 15 years ago, if we wanted to add servers to our network, we would have to go and buy 15 systems that take up space, power, and add heat to the server room. Also, these servers typically aren't using all their capacity throughout the day. Virtualization is a technology that allows you to host one or more virtual systems, which we call virtual machines, on a single physical system. Basically, instead of buying a bunch of new physical gear, we can combine all that functionality into one single system. A few terms that you need to understand with virtualization include hypervisor, which is the software that creates, runs, and manages the virtual machines. This would be like the software VMware, Hyper-V, and VirtualBox. The host is a physical system that's hosting the virtual machines. Since hosts are running many different virtual machines, we need to consider the requirements like the RAM, the hard drive space, and processing power for all those systems, but it's still more efficient than having a bunch of different physical systems. Guests are the virtual machines that are being hosted. For example, if you had 3 virtual machines, you would have one host as the base layer and 3 guests. Host scalability is the ability to resize the computing capacity of a virtual machine. For example, if we want to increase the amount of processors for a virtual machine, we can do this, but it's usually going to be manual and it's probably going to require a reboot. Host elasticity is the ability to dynamically change resources that are assigned to a virtual machine based on the processing load. When we do this, it doesn't require a reboot. What happens if you want more secure computer deployments? There's a few options to consider that I've listed on the screen here and that we're going to cover. Thin clients are computers with just enough resources to boot in order to connect to a server and run specific applications. Most commonly with these systems, they're going to need a monitor, a keyboard, a mouse, and maybe speakers or a USB port, but they aren't that special to look at. A virtual desktop infrastructure, or VDI, is where the user's desktop operating system is actually ran on the server instead of that local system. We can't deploy containers to users directly, but they're a third option when it comes to secure deployments. Containers, or container virtualization, run services or applications within isolated containers or application cells. Containers are extremely isolated and they don't host a full operating system. However, they do rely on that host's operating system and they have to be compatible. So you can't run a container that needs Windows and the host is running Linux. Virtual machine escape, or VM escape, is an attack that allows access to the underlying host operating system in a virtual environment. These attacks are dangerous because a lot of hypervisors or virtual machine software run with elevated privileges. So if an attacker can escape, then they can have elevated rights to that host. Virtual machine sprawl, or VM sprawl, is something we also have to be concerned with, and that's when a company has so many virtual machines that they can't properly manage them all. Just because we have virtual machines doesn't mean that we should ignore the standard requirements that exist, like change management. We don't want to leave virtual machines unmanaged or unpatched. As far as our computers are concerned, virtual machines are simply files that exist. This makes backing them up or moving them fairly easy. Snapshots are a backup or a copy of a virtual machine at a point in time. Just like in a video game, we're saving the point at which we're at, which can be helpful if we want to make changes and something goes wrong, because we can just restore that snapshot. Persistent virtual desktops allow users to customize their desktop just like they would on their own computer. Persistent virtual desktops are going to require more disk space to save all those changes in individual desktops. Non-persistent virtual desktops start off the same for every user that logs in, and they'll allow changes while they're logged in, but once that user logs off, then that snapshot is going to be restored. We can take steps to deploy systems in a secure state. However, we're always going to have to continuously manage them so they continue to be secure. Let's shift gears and talk about some techniques that we can use to deploy secure systems and keep them secure over time. An endpoint in our network is any system that's connected. This can be servers, end-user computers, or anything else. Endpoint detection and response, or EDR, provides continuous monitoring of endpoints for us. Some of the technologies will include anti-malware solutions and host-based intrusion detection systems, or HIDs, but the key point is that they help us to monitor endpoints. Hardening systems is when we make the operating system or an application more secure from its default installation. For example, we can configure additional settings to be more secure. Some of the common hardening techniques include changing default credentials like passwords, removing unnecessary applications or services, modifying registry settings, and implementing disk encryption. The steps that you take are going to vary from system to system. Configuration management is the practice of deploying systems with secure configurations. For example, our golden image of the Windows 10 operating system that we deploy will have preset configurations to make sure that we're deploying the most secure system that we can at that point. One of the terms that you might hear frequently is something called a baseline. A baseline is a known starting point, and we typically use these for systems that we're going to deploy. Baselines give us a good and secure system to deploy. Baselines have 3 steps to them. First, the initial baseline configuration involves our initial deployment on the network. Next, integrity measurements for baseline deviation is when automated systems and tools like group policy detect changes and they automatically reconfigure systems. And finally, remediation might take things further and actually isolate the system, which requires an administrator to correct some issues. Master images or golden images are the version of an operating system that we deploy on our network. These images have been hardened to our liking and they're ready to go. Using a master image allows for a secure starting point because we know that system's hardened. It also allows for reduced costs by reducing maintenance costs and improving reliability of the images that we deploy. We don't want to have the same issues to fix 10, 20, or even more times because that costs the company money. Writing software is hard, and writing secure software is even harder. Even if we deploy secure software on day one, chances are that later, vulnerabilities are going to be discovered. Patch management keeps systems and applications up to date with current patches. It's a process that includes methodologies for identifying, downloading, testing, deploying, and verifying patches to keep our network secure. Typically, a lot of testing is done in an automated fashion and using a sandbox environment in case anything goes wrong. One of the worst things that can happen in a network is that changes are made that cause significant issues and there's no documentation on what happened. Change management is the process for any type of system modification or upgrade, including changes to applications. Change management provides 2 goals. First, it ensures that changes to IT systems don't experience unintended outages. The second is that it documents all changes. When there's a change that needs to happen, it's submitted for approval, and depending on the impact, a formal change advisory board might have to approve or deny that change. These boards usually have stakeholders from various departments in the organization to make sure that the business isn't negatively impacted. Application whitelists or allow lists are applications that are authorized to run on a system. Then application blacklist or block lists are applications that a system is going to block. The terms whitelist and blacklist can apply to a lot of situations, but the idea is that whitelists are more restrictive than blacklists because they only allow what's listed. Application programming interfaces or APIs are software components that give developers access to features or data within another application, a service, or an operating system. A lot of web applications will give some access to their APIs. Some common concerns with APIs include, do they have strong authentication? Also, authorization mechanisms to verify access. What about, does it use transport layer security to encrypt data when transferring traffic over the internet? The reason why these are so important is because APIs are susceptible to attacks and they need to be secured. Microservices are something else that's important, and those are code modules that are designed to do a single thing well. They receive a value and they respond with a value, and that's about it. Something that's important as far as protecting data on drives is the idea of disk encryption. Full disk encryption, or FDE, encrypts an entire disk. Some hardware vendors are now even manufacturing self-encrypting drives, or SEDs, that are also called hardware-based FDE drives. These kind of drives require you to enter credentials to use them. Many organizations today are interested in having systems verify the integrity of the operating system and boot loading systems. That means that there's checks to make sure that the operating system files haven't been changed. A measured boot is the process that performs all these integrity checks, and if the check fails, the system won't boot. When you boot up older systems, they would use something called the BIOS, or the basic input-output system, to perform basic checks on the system and for all the components. Newer systems use something called Unified Extensible Firmware Interface, or UFI, instead, which provides some additional features over the BIOS. Keep in mind that we still frequently refer to the GUI that handles all these settings as the BIOS. If you want to see yours, you can restart your computer and press the key displayed to enter setup. A lot of systems are going to use either F10 or the F12 keys. TPM, or Trusted Platform Module, is a hardware chip on the computer's motherboard that stores keys for encryption. The TPM allows for full disk encryption and performs a secure boot attestation process to verify the integrity of that system. Using a TPM, the system will perform a secure boot process to check the files against the stored signatures and make sure that nothing's changed. If files have changed, the system won't boot. Remote attestation is like Secure Boot, except it uses a separate system to check boot files. This whole process allows for a hardware root of trust because the RSA private key and public key are matched to decrypt the data. Windows has implemented a common system for full disk encryption called BitLocker, and it's worth looking into in your spare time. A key point about TPMs is that you can't add them to the motherboard and they have to come installed. You might even be seeing this with Windows 11 installations where it actually requires this TPM chip. A hardware security module, or HSM, is a security device that you can add to a system to manage, generate, and securely store cryptographic keys. There are even network attached and micro SD HSMs that you can get. HSMs use RSA keys just like TPMs do, but HSMs are different from TPMs in that they can be added to systems after the fact. Data is the most valuable resource in an organization behind the people. If companies are careless with their security, data can easily be exfiltrated by an attacker and shipped off to the highest bidder or published for the world to see. Losing data can hurt your brand reputation and customer loyalty, but you can also face legal action and fines depending on the data that you lose. Let's talk about ways that we can protect our data. Data loss prevention, or DLP, is a term that's had a lot of focus in recent years and consists of the techniques and technologies that we can use to prevent data loss. The technologies range from blocking USB drives and burning CDs to examining data that's leaving through email and other data transfer types. One common technique is to embed keywords into metadata of files, such as project name or data type, and then the DLP system looks for that keyword and stops traffic if it shows up. Rights management, or digital rights management, refers to the techniques used to provide copyright protection for copyrighted work. Copyright laws specifically apply to original works like books, music, art, and other intellectual property. DRM became popular with music when CD burning became a huge phenomenon in the early 2000s. Even with this type of protection, we still have to be careful because criminals are never going to follow the law. Removable media is any type of media that you can attach to your computer, like a USB flash drive or an external hard drive. This can also apply to mobile devices like cell phones that have storage capabilities. USB data blocker software and security policies can prevent the use of unauthorized removable media devices. DLP software can go even further and prevent unauthorized printing of documents with certain labels. All this software would generate audit events so that we can see when somebody's trying to download or upload data. Data exfiltration is the unauthorized transfer of data outside an organization. Data exfiltration doesn't just apply to attackers, but it can also apply to employees that decide to take data and run. Data can leave in all kinds of ways, including but not limited to removable media, email, and via malware. A common technique to prevent data types from leaving our network is to configure DLP systems to look for specific patterns, like social security numbers. Organizations also use data classifications and labeling, like confidential, private, and proprietary, to identify sensitive data. If our DLP system detects any patterns or labels that we identify, an alert is generated and sent to the security team. We can also look for encrypted data because attackers frequently would try to encrypt data and take it that way, and our DLP systems can't decrypt and analyze that data. Encryption is one of the best ways to protect confidentiality of data because unless you have the decryption keys, you can't see that data. We use encryption on data at rest, meaning that it's sitting on a hard drive, or in transit, meaning that as data transfers across the network. Databases also allow us to encrypt our data. We aren't going to typically encrypt an entire database, but we might encrypt certain elements like credit card numbers or social security numbers. Encryption and decryption consume a decent amount of processing power, so we want to make sure that we don't unnecessarily encrypt information that isn't sensitive or that we don't need to. Today, the cloud's more important than it's ever been. Companies are migrating data, applications, and even networking services to the cloud to maximize their return and minimize costs. Given this rapid adoption, it's important that you understand concepts about the cloud as a security professional because you'll likely need to secure it. With cloud service offering types, there's a few that you definitely need to know. The first is software as a service, or SaaS, which refers to any software application that's hosted in the cloud and accessed with a web browser. Some common examples include Gmail, Yahoo Mail, Salesforce, and the list goes on and on. From a security standpoint, we would be concerned with the settings in the application itself, and the provider would take care of the underlying servers, networking, and so on. The next type is platform as a service, which is a pre-configured computing platform that you add to. An example would be GoDaddy hosting, where the server and the operating system are maintained by the provider, GoDaddy, but then you can add things like WordPress, PHP, and other services. The key with this service is that we aren't responsible for the operating system patches or the networking gear. Infrastructure as a service is where the provider manages all the physical hardware, data center, and things like that, But as the customer, you manage the environment, including the operating system and any patches that are required. A good example would be Amazon Web Services or AWS that allows you to spin up EC2 instances, which are virtual machines in the cloud, and you have to maintain them. We might also use serverless architectures in this service type. Infrastructure as a service gives customers a lot of flexibility in what they can deploy, but it also requires more technical ability and resources to maintain those deployments. Anything as a service, XaaS, is anything that we haven't covered so far. This can mean databases, storage, security, and so on. The provider manages the resources, keeping things running like the underlying operating systems. The key point with all these service offerings is that you need to understand who's responsible for what when it comes to the cloud. There's 4 different cloud deployment models that you need to be aware of. First is public cloud, which consists of services that are available from third-party companies like Amazon, Google, Microsoft, and they're available to anybody that's willing to pay for them. These types of cloud offerings are considered off-premises, which means they aren't on our work site. Private cloud is hosted by an individual company, but the servers and the data are accessible to internal employees over the internet. We consider these on-premises because they sit in our buildings and we're responsible for the security of the data centers and maintenance of the equipment. Community cloud is a cloud environment where communities have shared concerns like security or compliance. For example, you might have all the police departments in a state sharing information, but nobody else can access it. And then we have hybrid cloud, which is a combination of 2 or more cloud types. Hybrid clouds are transparent to the user, so they can't typically differentiate which type of cloud that they're using. When it comes to cloud security, let's first talk about the responsibilities based on the deployment model. Then we can talk about how MSSPs or managed security service providers can help, and then we'll talk about controls that you can use to manage it in-house. When it comes to responsibilities in the cloud, it really does depend on what you've deployed and how you've deployed it. When we spoke about the service offerings of infrastructure as a service, platform as a service, and software as a service, we briefly touched on the cloud service provider's responsibilities versus the customer, which is our company. As a refresher, it basically works like this. Infrastructure as a service, we're responsible for securing the operating system, applications, and data. The provider manages the servers, physical storage, networking, and data center. With platform as a service, we're only responsible for the applications that we load and the data. The provider handles everything else. And software as a service, we're responsible for the configurations within the application, but the provider is responsible for everything else. Sometimes companies might want to use an MSSP to help secure their cloud environments. A managed security service provider, or an MSSP, is a third-party vendor that provides security services for smaller companies. Let's face it, for most companies, it can be challenging to get budget for security. So MSSPs are valuable because they can maintain skilled staff to perform things like patch management, vulnerability scanning, and network monitoring at an affordable cost. Ultimately, with MSSPs, we have to make sure that security is getting done, but it's a matter of who's performing which part of the security. Now let's move on to ways that you can manage cloud security yourself. There's a few categories of cloud security controls that you need to be aware of. The first one's high availability, which can be achieved in cloud environments by using load balancers and multiple availability zones in different geographic regions. That way, if something goes down, you can still rely on those other regions. Resource policies help us to control who can launch virtual machine instances and other services that might cause us to incur costs. Secrets management is making sure that all of our encryption keys and credentials are secure for our environments. And auditing is available on all cloud platforms and integrates into everything that we do. This allows us to see what's taking place on our account. With cloud storage, there's a few important things that we have to consider. First of all, with permissions, just like with any data storage, we want to restrict data access to who needs it. Encryption is important too, and it's available at rest and in motion so that, again, only authorized people or systems can access it. And replication is pretty easy in the cloud and allows us to maintain our data even if a certain location goes down. There's a few important terms regarding cloud networks that you need to know about. First of all, virtual networks. Just like in our data centers, we have networks in the cloud to manage nodes. We might also call this a virtual private cloud, or a VPC, and the systems within it are called virtual private cloud endpoints. We also have something called a public and a private subnet, which allows for appropriate locations and people to access the networks. This is similar to the internet facing and the intranet systems that we have on site. And then cloud networks allow for segmentation too, which allows us to limit communications to our networks. When we're talking about compute resources like virtual machines or EC2 instances, there's some important terms that you need to know about. First of all, security groups. allow us to manage permissions on what people can do. Dynamic resource allocation provides elastic resources, meaning that we can scale up things like RAM, storage, and power as needed. Instance awareness is tied to reporting and notifications because we need to be aware of the nodes that we have. Transit gateway allows us to connect our VPC to our on-premise network. And then container security allows us to protect our containers that we might launch. Cloud Access Security Broker or CASB software tools are deployed between an organization's network and the cloud provider to give a little bit more protection. We might use this type of software because the cloud just doesn't give us enough security for our liking. Just like regular data loss prevention software, we can have DLP software in the cloud too. With that being said, in general, a lot of the best practices that we do on site can also be done and should be done in the cloud. Next generation secure web gateways combine a proxy server and a stateless firewall into one. The idea is that all the internet traffic must go through this gateway for analysis. Some of the features include, but are not limited to, URL filtering, packet filtering, malware detection, and network-based data loss prevention. An easy thing to forget about in the cloud is that we need to use firewalls. Just like on-premise environments, we need firewalls to protect our cloud networks. In today's world, we're shifting more and more towards automation to eliminate errors and improve consistency in all that we do. Infrastructure as code, or IAC, is the idea of basically creating a script to create and deploy any infrastructure that we might need. It's a lot easier and safer to fire off a script than going into menus and potentially messing up a setting. When it comes to networking, we're in a world that's shifting towards software and programmability. You'll notice that more and more networking jobs are talking about wanting programming skills, and that's because of SDNs. Software-defined networks, or SDNs, are virtualization technologies to route traffic instead of using physical hardware like routers and switches. SDN networks separate the logic to forward or block traffic on the data plane from the logic used to identify the path to take on the control plane. Basically, the idea of SDNs is that companies are more flexible and able to move away from proprietary hardware. Software-defined visibility, SDV, refers to cloud-based technologies that help us view network traffic that some security devices might have missed. Edge computing is the idea of storing and processing data close to the devices that both generate and use the data. Whenever a device needs to access data from the cloud, it takes time, and that might not be acceptable where immediate decisions are necessary. Fog computing is the same idea as edge computing, but instead of one node, there's a network of multiple nodes that are sensing and processing data. Of course, the increase in nodes allows for better performance. When it comes to cloud security controls, an organization that you need to be familiar with is the Cloud Security Alliance, or the CSA. The CSA not only makes a CCSK certification if you're interested in cloud security, but they also created a cybersecurity control framework called the CSA Cloud Controls Matrix, the CCM, to help secure cloud resources. Today, mobile devices are more common in organizations that have remote workers or workers that need to be on the go, and they can pose serious challenges if they aren't appropriately secured. What are mobile devices? Well, most commonly, mobile devices are going to refer to smartphones and tablets, but the NIST Special Publication 800-124, Guidelines for Managing the Security of Mobile Devices in the Enterprise, is a document that you should start to become familiar with. There's several different types of mobile devices, but one of the main challenges comes down to the ownership of the device. If the device is owned by our company, we can manage and control it a lot easier than if it's an employee's personal cell phone. The deployment models of mobile devices that you need to know include corporate owned, where the company buys the device and issues it to somebody. Corporate owned, personally enabled, or COPE, which means that the company buys the device and issues it to employees, but they can use the device like it's their own personal device. BYOD, or bring your own device, allows employees to use their own device, and then we might use network access controls to make sure the devices are patched or wiped if they're lost. And CYOD, choose your own device, is similar to BYOD, except we identify devices that we want to allow based on model, operating system, and so on. Then the employee can either go purchase one of those devices or use it if they already have it. Mobile devices have several different connection capabilities, with each introducing its own security concerns. Cellular is the most common with cell phones and might be 3G, 4G, 5G, or whatever comes next. Wi-Fi allows users to connect to wireless networks. Bluetooth, which is frequently used for hands-free communication devices. NFC, or near-field communication, which is commonly used for payment systems where you can wave your device near the payment scanner. RFID, or radio frequency identification, transmits data over RF signals. Infrared is a line-of-sight technology that's commonly used with TV remote controls. USB, or universal serial bus, can be used to connect to computers For example, your iPhone can use its charging cable to connect via USB to your computer. Point-to-point connects two devices together using Bluetooth, NFC, or RFID. And point-to-multipoint, which creates an ad hoc network allowing multiple devices to connect to each other without an access point. Mobile device management, or MDM, includes technologies that we can use to manage mobile devices. Some vendors sell unified endpoint management, or UEM, solutions to manage mobile devices. MDM concepts and capabilities that you need to be aware of include application management to restrict the allowed applications, full device encryption to protect locally stored data, storage segmentation to separate corporate and personal data, content management to apply further controls on corporate data like forced encryption, containerization to create an encrypted container on a mobile device instead of encrypting that whole device, passwords and PINs, just like on computers, where we can control the complexity and the length. Biometrics can require a fingerprint or a facial scan to unlock a device. Screen locks allow us to lock the screen after so many minutes and wipe the device if too many failed attempts are detected. And remote wipe allows us to fully wipe a device if it's lost or stolen. Some additional features that MDM solutions have include geolocation, which helps us locate lost or stolen devices, geofencing, which allows us to create a geographic region where certain applications are allowed to run. For example, if we want to only allow our sales application to run on our site. GPS tagging, or geotagging, is the location metadata included in pictures or files that might be posted to social media. This is obviously a concern if we don't want to disclose our location. We can also use context-aware authentication if we want to use multiple factors like geofence location and time of day to authenticate a user and their device. And push notifications can be sent by MDM solutions for a variety of reasons. When it comes to mobile devices, if a device is non-compliant, then corporate-owned devices will automatically fix the issue, like downloading a patch. Personal devices might be blocked from accessing the network. Let's talk about some common issues that MDM solutions look for. When it comes to applications on mobile devices, we want to leverage the vetting process that Apple, Google, and other official stores provide and not permit outside third-party store applications. Jailbreaking on iPhones and rooting on Android devices are similar ideas that give users access to more of the system than the manufacturer normally grants. This can lead to problems like giving users system or administrator level access on a computer. Android devices can allow custom firmware with various features that overwrites the manufacturer produced firmware. And sideloading is another concern when a user copies the application packet kit, or the APK, which is essentially the application, to a device and then activates it. This is like installing software on your computer from an untrusted source and could have security issues included. Standard SMS and MMS messaging, also known as text messaging and multimedia messaging, can be of concern because they're sent in plain text, meaning that they aren't encrypted. MMS is also known to allow remote code execution for attackers. Rich Communication Services, RCS, is a protocol designed to replace SMS for text messaging and has some additional improvements with it. As you know, cell phones these days have microphones and cameras that potentially can be activated on demand. MDM software can disable these features to prevent things like random pictures taken without a user's consent. MDM software can also prevent Universal Serial Bus on the go, or USB OTG, which allows other devices to connect to a mobile device using a USB cable, for example, a storage drive. Many cell phones come with a tethering feature that allows other devices to use the cell phone as a Wi-Fi hotspot. Cell phones can also be unlocked to work on different carrier networks. Both of these are examples of connections that we might want to disable with MDM software. Security Enhanced Android, SE Android, uses Security Enhanced Linux, SE Linux, to make an environment that denies anything that's not explicitly allowed. Since Android makes up a big chunk of mobile devices, this can be helpful in securing them. There's two modes you need to be aware of with SE Linux. The first is enforcing mode, which enforces SE Linux policy and denies any activity that's denied by the policy. Then we have permissive mode, which logs all activity that the policy would block if it was in enforcing mode. Embedded systems are any device that has a dedicated function and uses a computer to perform that function. A good example would be a lot of smart devices, like a refrigerator that actually has some flavor of Linux running under the hood. There's three main embedded systems that you need to know about for the Security Plus exam. The first is a Field Programmable Gate Array, or an FPGA, which is a programmable integrated circuit, IC, that's installed on a circuit board. When an FPGA is powered up, the configuration is loaded from memory. Since FPGAs load their function from a memory chip, You can swap out the memory chip and the FPGA will take on a new function. Arduino is a microcontroller board with a CPU, RAM, and read-only memory or ROM. Arduinos don't have an operating system and they're great for repetitive tasks. Raspberry Pi is a microprocessor mini computer that most frequently uses Raspberry Pi OS to run. Basically, this is a little computer. If you haven't seen any of my projects using Raspberry Pis, I highly encourage you to check them out. Internet of Things or IoT technologies are basically a lot of the devices that you're going to see with embedded systems. For example, remember when I was talking about that smart refrigerator? It doesn't stop with smart home devices either. It can also be in vehicles like a Tesla. Two more important terms that you need to be aware of with regards to IoT and embedded systems are system on a chip, SoC, which is an integrated circuit that includes all the functionality of a computing system within the hardware, which includes the memory too, and real-time operating system, or RTOS, which is an operating system that reacts to input within a specific time. If these systems can't process the data or they don't receive it, then they can report an error. Industrial control systems, or ICSs, are systems within large facilities like power plants or water treatment facilities. Supervisory control and data acquisition, or SCADA systems, are systems that control ICSs. Both ICSs and SCADA systems are typically isolated from the internet to avoid severe issues like a total power outage. Common industries or uses for ICSs and SCADA systems include manufacturing and industrial, facilities like temperature monitors, energy sectors, and logistics. Embedded systems face several constraints, including compute power is limited due to the size of the systems. Crypto selection is limited because the systems don't have the compute power. Power because embedded systems either need power from their parent or from batteries. Range is also limited and typically wireless is required. Authentication is either not included or it's weakly implemented. Network configurations are usually limited and we might have to accept defaults. Cost is a balance with security features, and on embedded systems, it's usually about keeping the cost low. Inability to patch, sometimes we can't even patch these systems or vendors are slow to release patches. Implied trust, because we usually assume that these devices are secure, and weak defaults are typically implemented, again to keep costs down.